Hot chocolate, red well. Azure Cosmos, Dapper. Entity framework, Power Tools. Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shiro Jan.
Chris Lanson.
Martha Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Awesome. So we are live. Hopefully every streams are running just fine. So welcome guys and girls. It's next .NET Data Community Standup. My name is Jiri Cincura. I'm joined with Shai Rojansky from the EF team and obviously Chris, who is going to be presenting today us with some awesome topics. Hi, Chris.
Hey, how are you?
I'm good. How are you?
Can't complain. Everything's
Can't complain. Only the weather, right?
Oh yeah, only the cold temps, but that's not a big deal. I'm warm inside.
Awesome. So, Shai, can you introduce yourself?
Sure, yeah. I'm, for those who haven't seen the EF Community Stand-Up before, I'm Shai Rojansky. I'm an engineer on the team. It's been a long while, by the way, since we've done our last one, like a few months now, I think, and hopefully we're coming back to a regular schedule. It's really, really nice to be back, and thanks to Jiri for organizing and kind of, stepping up and doing all this. Usually, what's our rhythm now, by the way? If I remember correctly, there's a change.
The plan is to have one every month.
Okay, so we're going to be doing once a month, and yeah, that will hopefully allow us to organize very cool and interesting sessions with awesome people. So yeah, great to be back.
Awesome, thank you. If you don't know me, my name is Jiri Cincura. Quite difficult name to pronounce, that's fine. I'm also working on the EF team as an engineer together with Shai, and I was visiting the update conference in Prague last year in November, if I'm not mistaken, and I saw a session from Chris about a lot of different ways how you can like optimize your efcore queries and efcore usage, and I decided, hey, this could be a great topic for our community stand-up. Obviously, his session was, I don't want to say longer, but it was packed with more information that we can fit into this community stand-up. So if you are interested about having more information from Chris, definitely check some conferences around you or his website where he's talking and whether this session is on the schedule, I definitely recommend it. It's a lot of great content in there. And today we will show you a small subset of this one. But for those who don't know Chris, can you introduce yourself?
Yeah, so my name is Chris Woodruff. Everyone just calls me Woody just because there's just a lot of Chris's. And my last name it's naturally Woody. So I'm in Michigan. I'm in Grand Rapids, Michigan. Been doing IT stuff and software development for 30 years now. So professionally, and been doing it since 1981 when I got an Apple II, a used Apple II computer, and started doing BASIC. But yeah, I work at a company called Real Time Technologies. I'm a solution architect. And like you said, I also speak at a lot of stuff. I've got a podcast called Breakpoint Show. I'm trying to blog more, so I'll have some information about that. I'm trying to do a blog post every day in 2025. That's my goal.
Nice. I saw that you started the series on C# and Rust, right?
Yeah, so I've got a couple more days on that one, and then I jump over to there's some data stuff, and I've got some entity framework core stuff coming out. It should start either probably Saturday or Sunday, and I've
Nice.
got 16 or 17 posts for that talk about lots of different data and entity framework stuff. But yeah. Yep.
Great. And if I'm not mistaken, you also wrote a book last year. If you want to plug that in.
Oh yeah. I wrote a book on network programming in C#. So you can either read the book at c#-networking.com, or you can go out to LeanPub or Kindle, Amazon Kindle, and buy the book. So I try to do it. If you do want to read it online, it's free. But if you do want to buy it for your Kindle, if you want to buy the ebook, it's available. It's not very much money, less than $20.
Awesome. So just a reminder for the audience, you can post questions in the chat on different platforms where we are streaming. Shai is monitoring the chat, and he will be answering your questions. If there will be some super nice and worth putting on screen question, we will do that, and Chris will answer it live. So if you have a question to the topic or something like that, definitely put them in the chat, and we will try to answer those questions as we go through. So let me bring a different layout with Chris's slides. And yeah, Chris, take it away.
Okay, so if you do want to get in touch with me or take a look at my blog, basically that's just some information. All the content I'm going to show you and code will be in a GitHub repository, and I will have a QR code at the end of this little talk, so you can get that, or you can go out to my GitHub account and take a look at it. But yeah, let's get started. So the first thing that I always tell people, if they want to kind of improve the performance of using Entity Framework, is to use DB context pooling, because there's not much to it. You change one part of one line of code, and you get the benefit of the feature in efcore. And it's surprising how many people haven't picked this up, and it's been in since efcore 2.0. So So hopefully people start using it, but let's run through it. So I've got an example here of a controller with a one action, just index. So when you start your ASP.NET application up, you have it, and you usually will put your DB context into your DI container, into dependency injection container. And typically what will happen is every time something needs it, it will go out and the DI container will create a DB context, and it will send that out to whoever called it. And so take an example, we had 3 web requests for this index in this controller, and 3 blog contexts were created. But imagine you have a website that's getting 1 million requests every minute. That's a lot of DB context that you have to create and take care of. So imagine you could set up a pool in your DI container, and at the start of your ASP.NET solution or project, Entity Framework Core will create a number of DB contexts in this pool that it will be used for kind of sharing out to whoever needs it, and we'll use those DB contexts. So again, if we have 3 calls to the same controller, we're actually not creating a DB context every time. We're just getting something out of the pool, handing it off to whoever needs it. And when they're done with it, it will come back into the pool. It will be stripped of all of its state. So it will go back to the original state, and we can get everyone kind of using those DB contexts over again. So by default, you get 32 DB contexts that are created in the pool. And you know what? I am going to now show some code, because let's go out. Okay, so I've got and this is a bunch of projects I have that you can find in the GitHub repository. But I've
Chris,
got,
you are probably having it on other screen, so we don't see your code.
How about that?
Yeah, I
Not
think
yet.
you're sharing the window, right, Chris, rather
I'm
than
sharing the
screen?
window, yes.
Yeah, so we're only seeing the window then.
Okay.
You'll have to reshare like the whole screen if you want to switch between windows.
Okay, so let's reshare that. Present, share, and then I'll just do the whole window, and we'll do that. Sorry about that.
No problem at all.
Can you see, okay, awesome. So I've got a little program that will run, and it will say, okay, we're going to go 10 seconds, and we're going to see how many DB contexts that we're going to create and use by not doing pooling. And then we're going to show 10 seconds of using DB context pooling. So if I run this, and let me do this, and then I'm going to run this without DB context to begin with. So let's run. Okay, so sorry. So I'm going to run this. And if you take a look down below, it's running. So going to run, and so we had 32 and we had 0 requests. So, okay. Oh, I know why. So you know what? We're not going to be able to show this demo because I do not have SQL Server up. So that was a kind of a bad thing to show. So don't worry. Let me go back. I've got the example sitting here in my my slide deck just in case. So I'm gonna go here. So to do DB context pooling, all you have to do is change where you add your DB context. Could be in configure services, wherever you add that DB context to your DI container. You just have to replace that.
You are still sharing your rider window, not the presentation. And by the way, prevent some questions because we get those
Sure,
questions.
let's have some questions. So
quite often the IDE Chris is using is called Rider. It's not Skin or Visual Studio Code or anything like that. So if you want to,
so I'm just going to share my entire screen. So
Google it.
Okay. Yeah, I'm using Rider today. So okay. You see my screen now?
Yes.
Yep.
Okay. Sorry about that. So all you have to do to use DB context is to change that one line from add DB context to add DB context pool. And that's all you get. And you basically get, I don't know if you guys have tried to figure out how much performance gain, but in some of my web APIs, I get around a 20% increase in performance just by doing DB context pooling. Do you guys have any ideas from the team side what a typical performance increase is?
Yeah, if you go to the docs, there's an advanced performance page in the performance section of the EF docs where the feature is documented, and there's a benchmark there, which, I mean, this is a few years ago when I think I ran this, and the code is available there. I'm not sure exactly what scenario is being tested, but it shows it basically shows a twice fold, which which I'm sure is that's very impressive. It probably is not going to be the case for many applications out there. I still 20% is absolutely amazing by just adding the word pool, as you were just saying,
exactly.
right? I mean, exactly. And in fact, that actually kind of begs the questions, right? It begs a certain question, which is, why is this not the default, kind of? And I mean, that's a whole discussion here, which I think is actually quite interesting.
Yeah, I view DB context pooling as more advantageous for web APIs and minimal web APIs and minimal APIs than I do for a normal for normal ASP.NET like Razor page applications I don't see as large of a performance increase with DB context pooling. You get some, but I see the biggest increase is when you're doing APIs.
Okay. Yeah. I mean, many times, if you're doing a lot of other stuff, like maybe rendering a template and various other machinery is happening there, then the savings you get from pooling the DB context start going down in comparison, right? Like it's all a comparative thing, right? If you're doing, for example, if you're issuing very heavy queries to your database, the SQL Server, it's not going to matter because most of the time is going to be spent anyway, just waiting for the database to, to process data, and that little bit is not going to matter. But for very fast, like APIs are basically do nothing except issue a query to the database, right, and then pack the results back as JSON or whatever, right? So there you will definitely see this kind of stuff dominating.
Yes.
And they also tend to, in many cases, issue very simple queries. Like if your query is basically get me something given its ID and there's an index on the database, that's going to be very fast on the database. And there again, you're going to start seeing the the overhead of context pooling like actually like shining through. But my question is still like, and I mean, I have an answer in my head, but it's a discussion. Still, why not just always have it on? Like even if for Razor, the gains are not big,
It's
what's
still
the
some.
disadvantage, right?
Yeah,
And
I think if I had my way, I always turn it on. So it doesn't hurt. I've never seen where there were any issues with it being turned on. So
right. So there is one thing that needs to be said, and that's the original reason kind of why it's not on by default. Context pooling starts to get a tiny bit more complicated if you run into a multi-tenant kind of situation. Basically, anywhere where the context starts having a state that's going to differ from context to context, like every request might have a different tenant, right? Or similar scenarios where every context instance is going to have something different about it, right? You need to, it starts to get a bit more complicated to wire everything so that state goes in. So the tenant ID for that DB context goes in. DB context pooling works perfectly when all your contexts are the same and all your queries are right. Then that's the perfect situation, and that is the majority, I think, of cases, out there in general. The moment you start having to have like state that varies across, then it's not at all impossible. It just gets a bit more complicated, and that's one of the reasons why, like back in the day, this is more older days, which were maybe a little bit less perf oriented than I would have liked. We were kind of like in this mindset of saying, let's deliver something that's going to perform reasonably and work in all cases, rather than let's perform something that's going to perform really, really well, like pedal to the metal. But then when you start doing like, multi-tenant, you have to start getting into these complexities, right? We weren't like all perf and by default, but and so on and so forth. And I actually just on the chat, somebody asked a question and I posted a link there. I pasted a link. We have a section in our docs specifically for how to combine DB context pooling exactly with multi-tenant. It's not complex. People should not be like, the takeaway shouldn't be like, oh shit, if I'm doing multi-tenant, I can't do DB context pooling. That's not at all it. It's just you have to jump through an extra hoop or two, and then you're fine. But you do have to deal with it in general. And actually, I'm going to echo what you just said, Chris. Sorry, I'm on a rant. And I'm gonna shut up in 1 second. This is just one of my pet peeves or whatever. I would absolutely echo what you just said. If it were up to me, my default would be to always turn on DB context pooling. And if we weren't like very conscious about breaking changes, and if we didn't have backwards compatibility like such a strong consideration, I would argue for changing the default and efcore and making pooling on by default. But that would be a bit too disruptive, maybe for people.
There would be someone out there that was some big enterprise that was using ASP.NET and Entity Framework Core, that it would break something. So that little code example that I thought I could run, I actually have posted on a slide the result. So if I don't do pooling, in 10 seconds I create almost 65,000 DB contexts. Now, this differs every time you run it, depending on whatever is happening on your computer. And then the request per second is a little under 6,400 requests per second. Now, if by turning on DB context, again, I get 32 DB contexts that are created. That stays constant the entire time. But it's amazing that I can get almost 16,000 requests per second. So we are getting over 2x performance gain from a request per second doling out and giving out DB contexts to our application resources. So just a little kind of insight into what you can do, and it's going to vary by how you use those DB contexts and everything, but you're going to get a good performance increase. So that's the first thing that I always say. Take a look at DB context pooling and see if that will help.
It's also worth noting that it's not only about like raw performance. It might also mean in cases that you don't need like 15,000 or 16,000 requests per second, but that you can deploy your application into a smaller VM or smaller container and get the same performance as you are getting now with less resources. Like if you are doing 1 request per second, it's not like pedal to the metal, but that means you can maybe deploy to container instead of 1 gigabytes of RAM, maybe 512 megabytes or something like that, and have a little bit more density with your application.
You're right. Instead of having to hydrate and give out thousands at one time, you're really using 32. So you are using less resources, which in the case, if you're running up on Azure, you're going to need a smaller VM or a smaller app service resource instance. So that's good. Or it's going to save you money in the end. So I know the business side always likes to hear less money.
There is one special comment that I would like to bring in, especially for our presenter. So you have quite an audience between the people.
I think he might not. You might not be seeing this.
I don't. I can't see it because I've got.
You've got a Matthew Groves from the crowd saying hi.
Matthew's out there. Okay, well, hi Matthew. Good that you're out there. You know, it's good. I posted it a couple days ago that I was going to be on this, so I'm sure I'll get some people, and I'm sure I'm going to get lots of good feedback to things that I forgot or I should have said. So please let me know if I say something or I should have said something. You know, I love getting critical feedback from everyone. But do you guys want to keep going with DB context pooling, or do you want to go to the next topic?
There's at least one question there.
Okay.
Usually, maybe you can highlight it because I don't have administrator on this. The one on that starts with 7 years ago. That's actually a topic I wanted to raise. Exactly.
Cool.
7 years ago, I ran into a bug using pooling and async methods, which would exhaust the connection pool. But it was fixed, so let's hope no other problems arise when pooling is being used. That's a trick question. For kind of, I view it as a trick question. Any kind of responses from you guys?
No, I don't actually remember that. But if that was 7 years ago, that would have been shortly after this feature came out, right?
Right. So I think the main point here is
async over sync.
So I think the key point here in that comment is talking about connection pooling, whereas we're talking about something different. And this is we're talking about DB context pooling, and that's a constant source of confusion for people, which is why I thought it might be good to like disambiguate and make it clear in people's minds what this whole thing is about, right? So DB context pooling is an EF feature. It's about the DB context, which is an EF type, right? Chris explained this, or Woody, sorry, I'll just use your Woody name instead. Woody just explained this like very well. Every time you need a DB context, EF will instantiate it unless you have pooling on it. Connection pooling is something completely different. A database connection is something that's managed at a lower level in the ADO.NET in the database driver, right? That has nothing to do with EF whatsoever. So if you were using something like SQL Client for SQL Server, or MPG SQL for Postgres, or Yiri's Firebird driver for the Firebird database, then I don't know about Firebird, but most database drivers also have a connection pooling mechanism, which even if you don't use efcore at all, let's forget EF for a second. You're using you're writing your own SQL, no link, no nothing. You're using maybe Dapper, or you're writing literally ADO.NET code. There is a connection pooling mechanism inside the database driver, so that you don't have to establish a network connection to SQL Server every single time you want to do something, right? Because that's a ton of overhead. It's much more overhead, by the way, than instantiating a DB context. It's far more important. Connection pooling is far more important than EF's DB context pooling, or just like in terms of how much performance that takes. Those two things are completely separate and happen at two completely different layers. So you can, by default, database drivers have connection pooling on, whereas EF has DB context pooling off by default, and you can turn either one of these on and off, and those don't affect each other. Okay, so regardless of whether a DB context is pooled or not, whenever it wants to do something with the database, like execute a query, it's going to go to the database driver and say, hey, give me a connection. And that database driver, if it has pooling enabled, if it's not been disabled by you explicitly, it's going to get a connection out of its own pool to be used by the DB context of efcore, which might be pooled or might not be pooled, right? So I hope this all makes sense. I'm kind of, right?
That's awesome advice. You know what? When you told me the question, I didn't pick up on connection, but yes,
I know.
And,
I know.
And you know what? When this was almost 30 years ago, I was using the very first version of SQL Server, which is a whole different story. But
oh yes.
And we used to have lots of errors because we were using too many. We would reach a point where we couldn't get any more connections from SQL Server back then. So I remember those days fondly. But yeah, the drivers are a lot better today, and they do a much better job with pooling connections.
Exactly. Yeah. And once again, people don't usually need to think about connection pooling like when they start out. It's just a capability of the driver. You do need to think about it when you're starting to tune. For example, you might want to tweak the maximum number of connection pools. That's all unrelated to EF completely. And people regularly kind of conflate these two things, and they come to the EF repo and say, hey, my connection pooling is not working well, and vice versa. There's tons of confusion there, which is why I'm kind of spending a few minutes discussing this. You really, I really advise getting these two different types of pooling distinct in your mind, like when you're approaching your database application, basically.
Yeah.
That was my
the other question I get when I do my EF talks and my EF performance talks is, can that number of DB contexts that gets created in the pool, so it's always 32. I always get asked if that number can change, if we can increase that number, and I always say no. But now that I have the experts here, one, can you do it? And if you can't, is there going to be a way to do that in the future with a future feature?
Sorry, can you repeat? Can you do what? I'm sorry.
So by default, you get 32 DB contexts when you
I see
your pool. I always get asked if you can increase that number.
You can.
And you
absolutely can. Yeah. So when you do add DB context, add pool DB context, that function that you were just showing, that has an optional parameter that will allow you to tweak exactly what the pool size should be, basically.
Awesome. Good.
We had arguments about this value back in the day, by the way, just for fun. Like, if you set this too high, then basically you're hogging up a lot of memory. You're going to have like 1,000, contexts there hanging out around in memory and just hogging memory for no good reason, right? So it's also a thing that you can tweak so that you're not, keeping these things in memory beyond what's needed.
Great. Okay, well, I guess I set you guys up for a softball because that's good. So you want to jump into the next topic?
Sure, go ahead.
Okay, cool.
I'll maybe mention one last thing just before you do
Sure.
this. Sorry, I'm really kind of I'm ranting a bit too much, but I do want to just stress that this is not an ASP.NET or a web or even a dependency injection feature.
Yeah.
You can very well use the DB context pooling also in your normal console application or any environment. So the API looks a little bit different because what Woody showed was obviously an ASP.NET DI application, dependency injection. So the API for setting all that up is specific to DI. But then we also have a pool DB context factor. I hope I'm getting the type name right. I'm not sure, which you can just new up directly like this. You give it the EF options, and then you can request explicitly. You just tell it, give me a context, and that's it. And so you can use DB context pooling in any efcore application, no matter what. And that is recommended. Once again, wherever you care even a little bit about perf, just use that, and you'll get free perf. It's really
Awesome.
a free lunch.
That's awesome. Good. So compiled queries. So I remember, this was probably, and tell me if I'm wrong, I think compiled queries was a efcore 3.0 feature. Is that correct?
Wasn't it even older? I'm not sure anymore. That's a great question.
Well, it was 2 or 3, I believe. And it came out, and I started really loving it, and started coding it and showing people. And for a while, it wasn't really a thing that was recommended. I think it's gotten better in the last couple versions of efcore, but I find that it really improves the performance of your application. Now, when I say compiled queries, I actually mean these queries get jitted down once, and I'll show you what I mean by once. They get jitted once, and I can use them over and over again. So just like with DB context, if you don't use pooling, basically Entity Framework will keep creating, or the DI container will keep creating these DB contexts and giving them out. That's the same thing if you have just normal link queries in your application. Now, depending on how you program, those queries may not have to be jitted every time, but sometimes the way our applications work, a link statement in EF core will be jitted over and over again, potentially. But with compiled queries, you're actually compiling them. You're going to compile them. They're going to be jitted, and then you can use them over and over again by using delegates and lambdas or lambdas. So I'm going to show 2 ways that you can compile a query. So the first one is with this is a lambda. I always get lambdas and delegates confused for some reason. So what I'm doing is I'm having a feature called ef.compileQuery, and this comes from the EF core, just the main NuGet package.
Correct.
And you can see where, and if I'm saying anything wrong, guys, please interrupt me. So what's shown here is compile query. It takes in a DB context, and it takes in the parameters that you want your compile query to have at its disposal for the link statement. So as you can see in the second line, am saying underscore context dot albums dot first or default, and I'm just saying give me the album that has an ID that is sent in. So that will be compiled down, and that will be brought into that explicit query variable using that compile query. Or you can do a compile async query that will do, if you want something to be asynchronous. So, and that is by doing that. So it's really not hard. I'm going to show you how I do it, which probably will have these guys saying why or give me some feedback. But I'm going to go back out to Rider, back out to some code, and I for a lot of my test databases, I use Chinook, which is an old Microsoft SQL Server test database, demo database, and I like it better than Northwind or what was the other?
Northwind.
Northwind, or because you know what? I like Chinook because it's a online. It simulates an online music store, so it has lots of cool music like albums and rock bands and stuff like that. So we all know DB context. I have this Chinook context. Let's skip over this for a second. So we all have seen this where we have our create our public code, and then we go in and talk about all of our entities that we do. I do something a little different. So for every query that I want, and this is for a web API. So this is for an ASP.NET web API project. In my DB context, I create a number of compile queries. So these are just func pointers to a private static delegate, and I use compile query. I don't use compile async. I could, but I do this for every single query that my API needs. So as you can see, I do like underscore query album exists. So I do a query that just says, does this ID exist in the database? And then I say a get all albums, and then I say a get album that takes an ID. And then I may have some like get albums by artist ID. So I take all those and I put them in here, and then if I run all the way down, I then take those delegates and I expose them out from the DB context so that anyone can use those. So basically, if I go out to and I don't have if you had a controller or a data repository or something that needed to call that query, you call it from the DB context. So you would say underscore context dot get all albums, and that would return to you just like if you were doing a link statement to get all albums. But I find I like this method because if you use it with DB pooling, all of your queries get compiled when the DI container creates your pool. Now you get dinged with a little upfront cost with this, because when those say by default, those 32 DB contexts get created, it also has to go through and compile all these queries, JIT them down and get them ready for use from the application. But once you get over the initial like hump of getting all of the DB context created in your pool, all these queries don't have to be JITted ever again. You don't even have to know about them. So one, they're at all developers exposure or at their disposal at runtime. And it also is good, I find, as an architect and like a tech lead, we are kind of building all these queries in one place for everyone to use. Now that this is my preference, this is how I do it. There may be someone out there that says, "Oh, that's the worst thing I've ever heard," but I have had good exposure with this, and on top of pooling, I can get another 10 to 15% of performance increase in my web APIs. And I'm doing this more around web API, but you can do it in a normal Razor page or MVC application also. But I get another 10 to 15% increase in performance.
And it's worth noting that you compile the query only once because you're assigning it to a static variable.
Yep.
Which means it happens when you first create a context and the static variables are being like populated, and then you are just like caching out those benefits because it's just a static variable, so it's super fast to access it and everything.
Yeah.
Well, the question was
yep.
the upfront cost and whether you can make it like compile on demand instead.
You could you can do it you can do these compile queries wherever you want to.
Yeah.
So you could do them in if you use the repository pattern to make a data repository, you could put them in there, and then when you need it, when you create that data repository, you'll have them at your disposal. But the problem is you'll get a ding during the execution of your program. And if somehow you create more than one, if you create a bunch of data repositories or need that, you may be recompiling those queries multiple times, where I found by putting them into the DB context that and using pooling, you're only doing it 32 times by default. And the ding up front, sure, it may be a second, it may be.
So I do want to correct one thing. So as Yishi said, I think if I am understanding you correctly, as Yishi said, these are static variables. So yes. In my mental model, this compilation happens once, regardless of DB context pooling or how many DB contexts get initialized and so on. In fact, this whole thing, just so that this is clear to in people's minds, this is a completely orthogonal optimization that you can do with DB context pooling or without, and there's actually no effect, no interaction whatsoever between these two things, right? Because this is just a static variable that's getting initialized when the type is first getting loaded or instantiated or whatever, right? So like, it's not like you should be doing this only if you're using DB context pooling or there's no relationship basically between the two optimizations that we've been discussing here. It's just a point I wanted to.
Yeah. And then Matthew also has probably wouldn't want to use something like that in an Azure function.
I have a lot to say about that.
Yeah. So maybe I haven't thought about that, Matthew, but yeah, Azure functions are special little creatures that we have to have different thinking around.
But also usually Azure function is not running hundreds of different queries. The function itself is small piece of code that's executed a lot of time on demand.
Yeah.
So that might be one or two queries usually, and not like hundreds of different queries, I would say.
Yeah.
So I'm seeing lots of questions around this theme in the chat. So I'd like to kind of like put some order in here. So first,
Sure.
there's a nice point here by Manuel that you could use the lazy pattern. So .NET has a nice type called lazy. You do lazy of something, and that just means it gets lazily initialized when you access it the first time. So if what you want to do is delay I'm going to use the word query compilation. That's what we use in NEF itself. So the point at which the query gets compiled, if you want to delay that until first use, you can absolutely do that with the lazy pattern. And that, for example, would address the Azure Functions problem. That means that your application starts up relatively quickly. And then the first time you access it, then you get a hit, right? Because then the query has to get compiled. The second time you access it, it runs really, really fast. That's basically the thing here. And another thing is that where you store these variables is again unrelated to whether to the speed of things, right? Like you can put them on the same context, or you can decide you prefer having like a repository per type, which is a pattern, and it doesn't really matter at that point. Like, sure, I mean, it does matter in the sense that if you put them on the repository, then the repository has to get used in order for those static initializers to kick in and so on. So yeah, it might change things a little bit. But if your goal is basically, for example, to delay and make everything lazy, just use the lazy thing, and then it doesn't really matter if they're all on the context or on the repository or whatever. So I'm just saying, like,
no, that's awesome. I mean, and that's the thing. I mean, I don't know everything. That's why I love talking to people like you guys or the people out in the audience, because it makes.
But you said it right. You said it 100% right. Like, your preference here is to use is to just put everything on the DB context. That's very valid. That kind of makes your context sort of the repository for everything, rather than, right, which is a perfectly valid approach in my personal opinion. Then there's some people want to have another repository, which like another thing wrapping the context, or maybe a repository per type, which is another valid thing. I'll also point out that let me step back here for a second, right? So the first optimization that we saw, the DB context pooling, the lovely thing about it is you just add the word pool in one place, and that's it. You're done. You got like tens of percents of speed up for nothing. You don't have to change your code in any way. This is a very different kind of optimization in that you have to structure your code very differently, right? Yes. One of the nice things about LINQ, which is lost here, right? One of the nice things about LINQ is if at some point you want to do a query, you just go and write a LINQ query, right? And then it queries the database, and you can have them anywhere in your code, wherever it makes sense. Whereas this pattern, which once again, I think is great, means that you have to now think about concentrating all your queries in some place, maybe the DB context, maybe the repository, it doesn't matter, but you now have to sort of architect your application differently. You have to think about function names like album exists and get all albums, rather than just running a LINQ query at the point where you want to, right? Some people hate that kind of thing, and they just want to do LINQ queries wherever they want. And other people actually love this because it kind of, it makes it very clear which operations are being, which queries exist in your program. It's kind of like more rigid and structured. It can also help. I mean, that's a completely different thing, but it can also help with mocking and with testing. So basically, if you want to mock your queries so that you can run a test and say that the album exists, return like you want to mock it, you want to control what that thing returns. This is the ideal place to mock, right? You have a function that you can now mock. Basically, you have an abstraction which you can mock. Whereas if you're doing regular LINQ everywhere, that's unmockable. That's a basically unmockable pattern. So there's many things here, which I'm talking about at the same time.
Yeah, and that's why I mostly do this compiled queries around my web APIs and minimal APIs, because I know what all those endpoints are going to be, and they're not as dynamic as other web development kind of patterns.
Sure.
So
absolutely.
Yeah.
Like
Yeah.
I would kind of say, you know, there's several questions here. Like regardless of this optimization compiled queries, some people like to organize all their link queries in a single place. Like one point that was made here by Matthew Groves is I think consolidating queries like this can help better manage indexes too. By which I think he means, because you have all your queries in a single place, so it's very easy to just take a look and see, okay, you know, I'm filtering by this, you know, by this property, by this column, so I want to put an index on it. It makes it very visible. You have your catalog of queries in a single place. So if you like this kind of architecture design, then you probably want to do it regardless of this optimization. That's kind of also what I'm trying to say, right?
Yeah.
If you hate this kind of design, then then you know, this optimization is sort of locked. You can't use it. There is some interaction there, but kind of think about what this does to your application architecture as well.
Yeah, and you could mix and match if you had half of your queries you could do
You absolutely
compiled,
can.
and the
Absolutely.
other half that you could kind of have a little more dynamic. That would be
Precisely.
a good thing. Yeah.
And that leads me to, I think, one last point that I wanted to say about this before we move on to FromSql. So first of all, I'd recommend, like there was a question up above, so when should you use this? So you can use this for every one of your queries if you want, but unless you're like, you want to have like this consolidation for all your queries, unless you're looking for that specifically, I simply advise using this optimization for your hot queries. So if you have one query that's run once at startup or whatever, you don't need to optimize it. There's absolutely no sense, and you can still do it if you want, but there's no sense in it, right? Whereas if you've profiled, you've actually looked and seen, you've kind of studied your application, and you know that there's these two queries which are super important. They get executed all the time, basically. That might be worth optimizing, right? So it's all about what you want to optimize. And with that, I do want to say, like, just so like a bit more deeper in what exactly this does, like what does it mean that you have a compiled query? So just so people have the correct model in mind, when you run a link query, regardless of this thing, then doing all of what EF has to do is super heavy, right? It gets this link query as an expression tree, and it needs to translate it to SQL and generate code to read the results back. It's an incredibly heavy thing. If we did this every single time, EF would be extremely slow. It would be unusable, basically. So EF, regardless of compiled queries, that's the point I'm trying to make, already has a caching mechanism inside of it for queries. And the first time you run a query, that's going to be very heavy. That's your startup time. The second time you're going to run it, even without compiled queries, it's going to be fast. It's going to basically see that the query is already in the cache. The same expression tree is already in the cache, and it's going to basically jump over the entire process and basically just basic caching, which is done everywhere. So
Yeah.
what is compiled queries about? The thing is that there's still some processing that has to happen before we can actually get to the cache. That is basically, so there's a few things that we need to do to the expression tree. There's a few pre whatever processing kind of things which do have to happen every single time, and those are the things that compiled queries kind of cut out, because they give you a delegate or a lambda which you can execute directly and jump over the entire thing. So it's not like without this, EF is doing the entire query compilation every single time. If we did that, normally EF applications would simply not work at all. Nobody would use EF at that point. But this kind of cuts out a little piece that's left, even though we cache our queries. And in that sense, this, what I've seen in general from my benchmarking, this optimization is nice, but it is much less powerful than the DB context pooling in terms of how much actual percentages. That has been my experience benchmarking.
I have too.
Yeah.
Yes.
You have to. That's good. Thanks for the confirmation. That's good. Like everybody, your mileage may vary. So what I absolutely propose is that people just benchmark their actual queries and see what this does. But this optimization, it requires you to change your code, because you have to like have those lambdas and consolidate them and so on. And it gives you relatively less performance advantages compared to DB context pooling, where you just add a word and you get more performance advantages. This is why, for me, if you're looking to optimize your EF application, absolutely start with DB context pooling, and then carefully review whether you also want to do compiled queries. That's what I'm generally more careful. I don't push this optimization onto people right away. I think it's valuable for those very hyperf-oriented applications. It is absolutely a thing to look at. but it's not something I would recommend people do by default, because it changes the way your application looks like. It's more, you know, it's a whole thing for
Yeah.
something that's a bit less.
It takes a little more coding. It takes a little more upfront work to do. And like you said, it also locks you into those that rigid query process where you can't do a lot of that linky stuff
Exactly.
that .NET developers love. But I think that segments into from SQL really, really well. And I like from SQL. So from SQL is this way to do, to do those complex queries that that you may not know how to build in a link statement. And you know what? There's probably not a whole lot, but if you've ever worked with DBAs and really good DBAs, they may give you some queries that you can't build in Link. So things that maybe do unions or just things that you maybe can do in Link, but the work to figure that out may be tough. So sometimes it's actually much better, in my opinion, to use from SQL for some situations where your queries get very complex. Now this query is very simple. It's just getting customers from a city, and we have a variable that's a string variable of city that takes in Redmond, and we use from SQL. And what happens is, people are probably going to go, oh, SQL injection. Well, the good people, like you're seeing here, the good people on the EF core team figured out, nope, it doesn't cause SQL injection. What happens is we send over, think of it, you send over, in this case, two things. We're sending over a query, the actual query going in SQL going to the other side, and it contains a variable. In this case, it's a @p0. And then a second piece of information gets sent with it that is the string that will go into that variable. And it is SQL injection safe. Now, if you use from raw SQL, now that's another way that we can work with SQL. I'll say base SQL is by doing from raw SQL. Now that will open yourself to SQL injection, but if you do from SQL, then you'll be safe from it, because when it gets over to the in this case, let's just say SQL Server, when it gets a SQL Server will take all that information and create the select statement in this case, and then send back what you want. I just want to remind everyone that if you're using from SQL or from SQL interpolated, any one of those things where you're actually adding your own SQL statement, what gets returned has to match the shape of the of a entity that's in your efcore DB context. So I couldn't come back and say in this select statement, give me the first and last name of the customer. Now, if I return that, it would give me an error because if there was also other things like telephone number and email and other properties that the customer entity class was anticipating, then it wouldn't match the I'd say the shape of the entity class. So that's one thing that you have to really make sure that you do. Or you could do an anonymous. There is ways to do keyless if you want to go down certain roads. But the other thing that I like to talk about is you can do link even if you're using FromSql. So in this case, I'm going to do a FromSql, and I'm going to give a select, and I'm going to do a DBO search blogs, and I'm going to send in that search term, and I can still do a dot where or dot order by descending. You can do anything with that, pretty much everything with that, with all of your nice link, I'll say link accessories. So this is just a nice thing. And I use it, and I'm going to say a dirty word here. I use it for stored procedures also. So I can do an exec. I can exec a stored procedure, and I can send in the parameters and stuff like that. Even though I think there's some stuff with Entity Framework Core now with stored procedures, stored procs, but the guys will tell me if I'm saying something wrong. But that's kind of my quick kind of case for using FromSql. I use it again if I have a very complex SQL statement or select statement that either I don't want to spend all the time to figure out how to do it in link, or maybe I can't. And link's great, but link doesn't cover every single case that you're trying to do in SQL.
Absolutely. And I would say store procedures are definitely not a bad word or anything. I think it's another tool in your toolbox. And if it makes your query do it like 10 times more efficiently, definitely use store procedures, use functions, because it's what database offers. So yeah, absolutely fine.
So so tell me what I said wrong and didn't say. And
I
I
didn't
said
say anything wrong, as far as I know. It was all
good. Awesome. Well,
I do have a couple things to add, but I mean, this is a perfect introduction to that, like to the SQL APIs. Like specifically for stored procedures, for that case, EF has features for saying that a DB set, when you read from it, instead of reading from a table, you can read from a function, basically. So you can actually map a DB set to a function or a stored procedure. It's the same in this kind of context. So if that's basically what you want to do, like just call a stored procedure every time that DB set gets queried, then you can do that basically without using this specific API, which just would make your code look nicer, but it's absolutely completely fine. I mean, basically, to repeat what you said, Woody, I completely agree. If you know the SQL you want, if there's like some efficient SQL or some SQL that EF doesn't generate for you, or it can't generate for you, maybe it's like very specific to SQL Server and there's no support for it or whatever, it's absolutely fine to go and do this, like absolutely fine. And some users think that they absolutely shouldn't be writing SQL. Not at all. It's absolutely recommended. You can absolutely do this for the right reasons, right? If you have the right reasons. You do lose something, right? You lose your static typing. You could get that string wrong. If you rename like a property, then you now have to manually fix up your strings. So you're taking on, some responsibilities by doing this, but it is, it's fine. If as long as you have proper testing, you'll discover these issues. It's going to be, it's okay. So we absolutely tell everybody to do this, but I do want to go back to the very first thing that you said. Once again, all very important and true. Every time you go and use SQL, do keep SQL injection in mind. I do want to say that. Now, as Woody said, if you're using FromSql, you're protected. You're basically, you don't have to think about SQL injection. But then there's the other one that Woody mentioned called FromSql raw. And unfortunately, I see a lot of people kind of just going and doing FromSql raw and not really thinking about it and using it where they don't need to do it. So the difference between FromSql and FromSql raw is precisely that FromSql raw does not protect you from dependency injection. The point is, FromSql will basically manage parameterization for you, but only where SQL allows it. For example, you can, like the cases which Woody showed, you just stick a parameter placeholder and it works. But in some cases, for example, you want to parameterize the table name or the column name itself. Exactly. You want like a right? You want a dynamic SQL basically that's gonna that's gonna select from this column or from that column or this table or that table. SQL does not allow parameterizing these things. Parameterization is not like a string search and replace. It doesn't just stick in the thing into your string. When you send the SQL to the database, it analyzes your SQL, it plans for your query, and in order to plan for a specific query, you need to know what is the table being queried and all that kind of stuff, so you can't parameterize that stuff. It's not a string search and replace. So if you do want to parameterize your, your table name, I would say first stop and think about what you're doing. Does it really make sense to do these very dynamic SQL things? And there's a good chance you might want to rethink your design. I mean, maybe. I'm not saying you're wrong necessarily, but just think about it. And if you've really reached the conclusion that you do want to do this, then your only option is to use FromSql raw, because that's the only thing there. You actually can interpolate the string, like the table name, directly into your SQL. And that is where SQL injection rears its head. The moment you're doing string interpolation, which is what FromSql raw can do, it can also do the other kind. But the moment you're doing string, you're around the string interpolation thing, then all the alarm bells need to go off. All the red lights, need to start spinning, and you have to very carefully audit what you're doing. So if it were up to me, by the way, we also had lots of arguments around this in the team years ago. I wanted to call FromSql raw something like FromSql unsafe or FromSql dangerous, or something that would have like a word on it that would tell you, please be careful if you're using this API. Whereas FromSql is the thing that if you can use it, it will not work in all situations. In dynamic query generation, it doesn't work. It only works for normal parameterization, but it is 100% safe. So that's something I really want people to come out with, like in their head. Don't use FromSql raw unless you really have a reason to do this. And if you do, be very careful and look at it very carefully.
Yeah.
That's my spiel.
So, if you want this code, and in my talk, I actually like blaze through a bunch of different stuff, and I talk about caching, and I talk about other features of SQL Server. But if you went out and got my slide deck and got the code, you'll see basically my whole talk. So, you can use the QR code here, or you can go out to my repository, just efcore perf demos. But that's about it. If anyone needs to get a hold of me, like I said, I'm out on Blue Sky and I'm on Mastodon. I'm not on X anymore, not on Twitter, but you can find me on Blue Sky and Mastodon, or you can just email me at cwoodruff@live.com. Always around to help people or answer questions, or if you want to tell me I was totally wrong about something on my talk, I love to get good feedback, and I've got a thick skin. I've been around this game for a long time, so got lots of scars. So I could take criticism really well. So, but yeah, I love efcore. I'm finding efcore is is faster and faster every single release. And I always have people that say, well, shouldn't I be using Dapper if I want real performance? And I go, I don't see much difference between Dapper today and efcore. So maybe 10 years ago, 7 years ago, that was the case. But yeah, so I have to give you guys your credit. You guys have done a great job with efcore inside the internals, making it really, really fast.
Thank you very much for saying that. And yeah, the team really cares about performance indeed. And we did a lot of work over the years. There was one release, I think it was around the 3.1 or was it 5? No, sorry, it was 5, I think, where we specifically kind of compared ourselves with Dapper and used it as a motivation to speed things up internally. You still need to know, if you want to get to like Dapper level performance, you need to do stuff like what you just showed, Woody, actually. Like if you do all the things that you just showed with DB context pooling and compiled queries and a few others, maybe you use no tracking queries as well rather than tracking, because tracking has an overhead. It must have overhead, like you're asking, you have to do a lot. So if you disable those and you do things in a certain way, that's not the default way, you can get very, very good performance out of efcore, and that's basically what.
And,
not everybody cares to that extent.
I do have that in here, the no tracking. So if you do want to, if you have an application like a web API or a minimal API that you don't care about tracking, I would use no tracking, because it cuts down on the overhead that that query and the code around it. If you want to do it for everything, I would just go in, and when you do your option builder, you can just say use query tracking behavior, and you can say no tracking, and it won't use tracking for anything in during the lifetime of your program.
Yep.
So I always kind of give that out, but that's another thing that's out in my talk in this slide deck that people can go and take a look at. So, but that's another way to kind of squeeze out a little more performance. I don't think it's a huge performance boost, but you may get 2, 3, 4% increase in performance by doing no tracking.
I've seen more. I'd actually recommend looking at it too. I mean, it all, again, your mileage may vary always, like everybody has differently, but tracking can have quite an overhead in some applications. And I would like, if you're, for example, you're doing a web application and your controller or minimal API Lambda just reads something from the database, there's no reason for it to track, right? Like, why would you track something if you're just reading it and you're not intending to update it back to the database? Tracking is about that, like, mostly, right? So I would like what Woody just showed is basically turn off tracking by default. And then for queries which do need to track, you can opt in that specific query by using an operator called as tracking, right?
Yes.
So you can flip things around rather than opt out on a per query basis. You can opt in to tracking on a per query basis, and that's probably not a bad piece of advice for a perf-oriented thing, although tracking is a very complicated thing. Like, its intersection with performance, that's like the subject for a whole other EF community stand-up, I think, unfortunately. And more out
I
of
think
time.
that's a great segue to kind of call for action for our listeners and viewers. If you want to see more of this, definitely let us or let me know. We can have Chris again and tell us about other parts, or even about different parts of the performance. Definitely we are listening for ideas for the content and feedback on what to prepare for the next show.
Oh, I've got tons of ideas. Every developer needs to know about query plans. And if you work in SQL Server, I would say just because your query gets data doesn't mean that your query is optimized. And you need to dig down into SQL Server or whatever your data store platform is and understand the query and how the queries are run down there. So there's
100%.
yeah, there's lots of stuff to, and
100%.
I even do a talk on that where I talk about query plans and how to find if your database needs missing indexes and stuff like that.
And some people make the mistake of thinking if they use efcore is such a nice high level thing, right? You just use link, you're not even writing SQL. Some people make the mistake of thinking that they don't need to, they just, they just express their thing with link and they're done, right? That's not the reality. EF only translates your link into SQL, and then at that point, the database just has to, run your SQL, and that means there needs to be a good plan, and there needs to be indexes powering that query correctly, and everything. So there's no replacement to knowing your database well, knowing what the query plans are running like for your hot queries. As always, like don't go and investigate queries you don't care about. Investigate those which you do care about, and that's absolutely a very important subject. I completely agree.
Exactly. I mean, there's tons of stuff. I mean, when you're talking data, there's lots of things to look at. So yeah, I love talking about data and everything. So I would love to come back on. I also have this thing about efcore migrations that I don't like it, but that's my opinion. I just think that most people don't know how to use migrations correctly to create a database. And that's where you really need to dig in and take a look at your query plans if you're using migrations to create your database. So yeah, I have a lot of opinions. Some aren't probably the ones that you guys want to hear, but I've just seen lots of really bad databases when people do migrations without really understanding migrations.
No, I don't think. I mean, I don't think we disagree that much. But yeah, that's a whole topic. That's a whole
nother topic. Yeah.
Yep.
Awesome, Woody. Great talk, great session. Thank you very much. We will keep in touch in case we have demand for more of this, and I'm pretty sure we will. So I'm pretty sure the viewers will see you on our show sooner or later. We will see. Thanks for your talk. Enjoy the rest of the day, and the same for our viewers. Enjoy the rest of your day, and see you next time.
Yeah. Thanks, everyone.